As you've learned in a previous video, the slope-intercept form of a linear equation is the easiest way to go from the equation to graphing. It gives you the slope and it gives you the y-intercept, and from there you can easily graph anything once you're in the slope-intercept form. But there are two other forms of a linear equation that you commonly see, but they don't lend themselves to easily graphing the particular line that they're associated with. First, there's the standard form, which we've talked about before. ax plus by is equal to c. You don't know the slope by looking at this, so for an example, if I put 3x plus 4y is equal to 12. Just by looking at it, you don't know what the slope is, you don't know what the y-intercept is, so you have to change it to the slope-intercept form to be able to graph it. And that's one of the next videos will show. The point and slope form, if you're given a point, say this line goes through the point 5, 8, and it has a slope of 3, then can you graph it? Well, if you have the graph right there in front of you, you can go to the point 5, 8, say 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8. You can say the point's there and the slope is 3. So down 3 over 1, down 3 over 1, down 3 over 1, and so forth. You can say, yeah, the line looks something like that. Okay? But you'd have to keep on counting to figure out where the y-intercept, and you don't know the equation for the line. So the point-slope form is a way to get you from, having one point and a slope to an equation, the slope-intercept form. So the point-slope form is y minus y1 is equal to m, which is a slope, times x minus x1. And the y1, x1 is just the point. If you say this is point 1 here, then this is x1, and this is y1. And the x and y that don't have the little subscripts next to them just stay as x and y. So using this point and this slope, we can substitute it in this. You can say y minus y1, which is 8, right there, y1, is equal to m, which is 3, right there, times x minus x1, which is 5, right there. Now you have to distribute, because you got the 3 times the x and 3 times the negative 5. So you can say y minus 8 is equal to 3x minus 15. Now if I want to get the y by itself over here, I have to get rid of this negative 8, so I add 8 to both sides. And now if those cancel, I get y is equal to 3x minus 15 plus 8 is minus 7. And now I have it in slope-intercept form, and I can easily graph that. I know the y-intercept is at negative 7, and the slope is 3, which I already knew because it's up here. Okay, so that's not going to change, but now I know the y-intercept. So that's the whole point. When you're given a standard form and a point-slope form, the whole idea is, can I get this into y-intercept form so that I can graph it? And that's why we use those.